In this video, we're going to go backwards. We're going to use proportions that we might have to find z-scores. So we can use the unit normal table, which I hope you have out now, and we can identify proportions and find their associated z-scores. Why would we want to do this? Well, sometimes all we know is the proportion that we're interested in. So let's say we're interested in finding out the z-score that sets off the top 10% of a distribution. And so 10% is equal to a proportion of 0.1000. So we're looking for 10% in this case, and we're looking for 10% in the tail because we're looking for the top. Whenever we're looking for the top of something or the bottom percent of something, we're looking in the tail regions. So what I'm going to ask you to do is take out your unit normal table. And like I just said, we're looking at the tail region, so we're going to be looking at column C. I want you to find the proportion that is most close or closest to 0.1000. Pause the computer and do that. So what we found is a proportion of 0.1003. That's the closest we could find to 0.100 or 10%. And that z-score, if you draw a line going to the left, is 1.28. So what that means is this z-score of 1.28 separates the top 10% of the distribution from the bottom 90% of the distribution. So a z of 1.28 is this boundary that we're talking about. Let's try another one. This one's a little bit trickier. Let's say I wanted to know the middle 60% of the distribution. Well, you might be thinking, great, I'll just look at 0.6000 in the z-table. But guess what? The z-table only goes up to 0.5000. So we can work with this because we know it's a symmetrical distribution. We know the mean is dead center. So that means between the mean and this top z is 30%, and the mean and this bottom z is another 30%. So what we're going to do is we're going to find the proportion of 0.3000 between the mean and the z, and that is column D. Look in column D for the proportion that is closest to 0.3000. Pause the computer if you need to. We looked in the D column. We found what's closest to 0.3000 is 0.2995. And the z-score associated with 0.2995 is 0.84. So what does that tell us? It tells us that the z-score that sets off the lower boundary of the middle 60% is negative 0.84, and the z-score that sets off the upper boundary of the middle 60% is a positive 0.84. So we have negative 0.84 to positive 0.84, and that encompasses 60% of the distribution. So we're going to do a learning check. I want you to pause the computer. I really want you to do these first. Find the z-scores that are associated with these following proportions: the top 5% in the distribution, the middle 95% of the distribution, the middle 99% of the distribution, and the bottom 15% in the distribution. Work that out and then come on back. The first item asked us to identify the top 5%, the z-score that is associated with the top 5%. Well, I need to do a couple things to get started. First of all, I know I'm going to be looking for a proportion in the unit normal table that's around 5%. Our unit normal table expresses things as decimals, so I'm looking for the closest I can to 0.05 in the unit normal table. The next question I have is, in what column am I going to be looking for the top 5%? Well, I don't know where it's going to be, but the top 5% is taking a certain level and going that way. This is going to be the tail region. So I'm going to be looking at column C to find a proportion that's close to 0.05 because I'm looking for the top, what's in the tail section. So let's take a look and see what that looks like on the Z-table. Here's a z-table that has the section that we're interested in. We were looking for the proportion in the tail that's closest to 0.05. Uh-oh. We have two that are equidistant, 0.0505, 0.0495. What to do? Well, we can draw a line over and we see that we have a z of 1.64 and a z of 1.65. What we're going to do by convention is we're going to pick the larger z. We do this, and you'll learn about this later, to make our statistical tests more rigorous. So when you are faced with two different z-scores that are equally of the same proportion that you're interested in, then you're going to choose the larger z-score. Conversely, you could also say it's a z-score of 1.645. You could split the difference. And even if you picked a z-score of 1.64, it probably would be okay too. But just as a matter of practice, we're going to pick the larger z-score of 1.65. Now that we know that we have a z is equal to 1.65, I can map that out on my graph. It's probably somewhere between 1 and 2, maybe it's about here, and the top 5% is in this tail region. And the z-score associated with the top 5% is 1.65. So if I'm taking a test and I have a z-score of 1.70, that means I'm well into that top 5%, right? So that is how we find the z-score that's associated with the probability of 0.05. Let's do the next one. The next problem asks you to find the z-scores that set off the middle 95%. So if I have 95% here, how much do I have in the tail regions? Well, 100 minus 95 leaves 5%, but it's split between two tails, so we have 2.5% in this tail and 2.5% in this tail, right? So what I'm going to be doing is I'm again going to be using column C because I need to know the z-score that's associated with 2.5% in the tail. So how do we write 2.5% as a probability or proportion? 0.025. So now I'm going to be looking at my z-table for the z-score that's closest to 0.025 in the tail. Let's take a look and see what that looks like on the z-table. For our next section, this is the area of the z-table that we're interested in. We're looking for something close to 2.5% in the tail or 0.0250. We have exactly that, don't we? Boy, we lucked out this time. That gives us a z-score of 1.96. But we were looking for the area that sets off the middle 95%. So that means that one of those z-scores is negative 1.96 and one of them is positive 1.96. Let's see what this looks like. Okay, now that we have our z-score of negative 1.96 and positive 1.96, we can set those off on our tables. We can show what is the z-score that sets off the top 2.5%, what is the z-score that sets off the bottom 2.5%. I'm going to let you know that we're going to see this a lot. This is a percent in the tail that we're going to use a lot in statistics. 2.5% on the right tail and 2.5% in the left tail. All right, let's try the next one. This next item asked us to identify the z-scores that set off the boundaries for the middle 99%. So if we have 99% in the middle, that means we have 1% in the two tails combined. So this is 0.5% in this tail and 0.5% in this tail. If we add these two up, they make 1%. So what is the proportion that we're going to be looking for in our unit normal table for 0.5% in the tail? First of all, we're looking at column C, we're looking in the tail. And this time we're looking for a proportion that is close to 0.005. That's the target. That's what we're going to look for. So let's take a look at that. So we're looking for something close to 0.005, and lo and behold, we have a tie again. Two proportions that are equally close to 0.005, but no worries, we're going to do what we did before. We're going to look at those two z-scores, but we're going to choose the higher of the two z-scores. And again, you could have just set it off and said it's 2.575 and split the difference, but 2.58 is perfectly acceptable as well. And so when we say 2.58, we know that we're looking at the lower boundary and the upper boundary for the middle 99%. So negative 2.58 and positive 2.58 are the z-scores we're going to be using. Let's look. So again, our z-scores that we found were negative 2.58 and a positive 2.58. So we interpret this by saying that the top 0.5% of the scores and the bottom 0.5% of the scores are in the tail when we have 99% in the middle. And the z-scores of negative 2.58 and positive 2.58 are the z-scores that set the boundary for that middle 99%. Okay, we've got one more. So for this last one, you were asked to find the z-score that sets off the bottom 15% of the distribution. We have 15% here, that means we have 85% above. So what we're going to need to do is we're going to again be looking for column C, we're looking in the tail area, for the z-score that has 15% in the tail. Another way of writing 15% is 0.15. So look for 15% in the tail. For this last one, we were looking for the closest thing to 15% in the tail, and we have 0.1492 is our closest, which gives us a z-score of 1.04. But remember, we're looking for scores that are in the lowest or the bottom 15%, so our z-score is actually going to be a negative 1.04. That gave us a z-score of 1.04, but since this is below the mean, it's a negative 1.04. So a z-score of negative 1.04 sets off the bottom 15% of the distribution. That's it for now. I will see you at the next video.